Today we're going to talk about carbon compounds, and this is our first video in production of materials. Essentially, we're reviewing the basics from the preliminary course, as well as adding in a little bit of extra, small information right at the end. All right, so here we have essentially these are the three types of carbon we really see. We talk about this one a lot. This is our radioisotope, and we talk about this one. This picture, you don't need to write that down, and I guess that's a test for the students who tend to pause and just write down everything that's on the thing and turn the sound off because they're doing whatever they're doing. Don't do that. Pay attention properly. This is the main carbon up the top here that we look at, and this one here is the radioisotope of carbon. This one here makes about 1% of all carbon found on Earth. We tend to not really talk about it at all, but it is an isotope of carbon. Now, basically, the whole point of today is to understand the basics of carbon compounds, in particular the hydrocarbons, although we will talk about alkanols a little bit, and this should provide a base for understanding the use of alkenes and when it gets into polymerization and making polymers, in particular biopolymers. Alright, so carbon. Now, basically, carbon has the electron configuration of 2.4. This means it has 2 electrons here in the inner shell and 4 in the outer shell, which means it's 4 valence electrons, which means it can form 4 strong covalent bonds. These can be single, double, or triple, although you can't have more than one triple bond attached to any single carbon because it doesn't have enough electrons to share. So the compound with only single bonds, so a hydrocarbon with only single bonds, we call that saturated because nothing else can join to it. Now we can form chains or rings, and if your chain is a where's that pen? If your chain is a straight chain like this, we call it a straight chain, but if it's got something coming off the side, we call it branched. Now the carbon can also form covalent bonds with other nonmetals, and this is really important. This is what gives us the variety of carbon compounds out there. Alright, hydrocarbons. So basically, if you've got just hydrogen and carbon in your organic molecule, you are a hydrocarbon. And this gives us the alkanes, the alkenes, and the alkynes. If we look down here, by the way, we can see the 3 different ways of writing these down. They should be familiar to us. You've got the expanded structure, the condensed structure, which we don't tend to use too much, but you'll see it written down a lot, or the molecular formula. There's also the just the skeleton one, which we can use, that there's 1, 2, 3, 4, that's 1 butane. Okay, so homologous series. Basically, that's the group of compounds with similar defining structures. Those defining structures that we talk about are the functional groups. So the defining group common to all members. Now this one down here is an alkane because it's only got single bonds, but the second you've got 1 double bond, it becomes an alkene. And it's whatever is the largest of those bonds, whether it be a triple or double, that you have in the main chain, the longest chain. Alright, so none of this should be new, except until we get about here. Now, carboxylic acids, we're not stressed about that. Let's not worry about that right now. We'll worry about that later in the year. But the alkanols, that's the new stuff for us. Now, over here we've got the structural formula of CnH2n plus 2O. Now, this is because each alkanol, has the functional group of OH, which we call a hydroxyl group. So that's a hydroxyl group. And this one here is methanol, by the way. Alright, so we'll come more to that later on. At the moment, we're going to talk about isomers. Now, isomers, if you remember correctly, they have the same chemical formula, molecular formula, but different structural formulae. In other words, they're different structures. So here, these are all isomers of pentane. Okay, so down here, they all have the same molecular formula, but different structural formulae. Okay, now branched chain hydrocarbons are isomers of straight chain hydrocarbons. Okay, you see that here. So here's 2-methyl, that's your methyl group there. Ethyl, that's your ethyl group there. 2-ethyl propane is the same formula as pentane. 1-methyl butane is the same formula as pentane. Now, if we're being technically correct, you would not call this 2-ethyl propane. You would call this 2-methyl butane. And you see that there. Because we talk about the longest chain, the longest straight chain. Alright, here's a little summary table. Make sure you get that down. And that's it for today. Okay, see you, class.